Hi, my name is Stephen Bourgeois, and I'm going to demonstrate a comparison between the Bus Pirate and the MicroMaster Mini. So the MicroMaster Mini is on the screen on my left, so in order to use the MicroMaster Mini, you have to know to press M, and that brings up the menu. So clearly you have to use a manual pretty much for everything in the Bus Pirate, and I'm going to show you that. So for I2C, we press 4, we can choose a speed, choose 3, and then we have to know this scripting language in order to get it to work right. So in this case, we'll go ahead and try to get that to work. All right, it didn't really work, but you can see basically how I2C works with the Bus Pirate. So the Bus Pirate has this clunky interface that's hard to deal with. Press M to get back to there. And now I'm going to demonstrate the MicroMaster here on the right. So if we press any key, the MicroMaster Mini version 0 comes up. All the pins are still in high Z mode. Press any key to continue. Okay, so here we have this system of pages. We have home page and all these other pages that you can go to. So you can press tab to tab through the pages. And if you see, if I hold down tab, it is pretty robust. So we'll start off page by page. So here on the configuration page, you can use the arrow keys to change these settings that do various things. We won't get into it now to try to keep the video short. But one thing that it does have is an adjustable power supply. You can choose between 3 volts, 5 volts, and 1.5 volts, as well as programmable pull-ups. So one thing that's nice is you can press H, and that'll bring you to a help page. Now, I haven't yet filled in these help pages, but every one of these help pages, for every page, there's a different help page. And when you press H, it'll come up and tell you exactly what's on that page and exactly how to use it, and any warnings, caveats, pitfalls, or anything else that you might find. So we go to the next one. We have an I/O control page. Now here I can use the up and down arrow keys to move the cursor, and I can turn GPOs on and off. And then similarly, for the GPIs, they can be read, as well as ADCs. I have it connected to a joystick over here. You can't see, but I can change those ADC values around by moving the joystick. Okay, so if we press on this page, this is an I2C search. This searches all the addresses on the I2C bus. So if we press spacebar, it does that, but this is not really lined up right. So let's try that again. So we see now it's lined up right, and we see that we have something at address 44. So this is a scripting page. This allows you to transmit messages, only transmit, not receive. So I'm just going to put in the code to initialize a light sensor, and we'll show you how that works. All right, message transmitted successfully. So we'll go to the next page. This is I2C command. This is where we can send commands to read and write to I2C. So we want to monitor the register, address 44, number of TX bytes 1, let's read register 00, and 2 bytes. And we press spacebar to send. It's telling us to tab to see the monitored register on the next page. We go to the next page, we see this number moving. And what we can do is we can use the cursor keys to change the format. So we go to binary, most significant bit decimal, and least significant bit decimal. This happens to be least significant bit. So if I put my hand over the light sensor, it goes down, and I remove it, it comes up. So you can see with this, what you could do is you could have a control register, and let's say an IMU, and you could record the control register in all 3 axes of, let's say, an accelerometer. And you could really see, how interrupts and limits that you can set, if they're actually working, that kind of thing. You can really get into the device. So this is a sniffer. Right now I don't have it set up to sniff anything, but what it would do is just print out all I2C bus traffic that's going on in live. SPI command works the same as I2C command, so we won't get into that. SPI monitor does the same thing as what I just showed you, except with SPI. Then we have UART command. We can choose the speed and enter a UART command. So let's go 11. 5200. Press enter. Then we can enter the format for text or hex. So let's go text, and we can enter some string, and it transmitted some message over a UART. So this is a streamer on the next page where we can stream messages that come in. This would be useful instead of having to use an FTDI cord or chip. You can simply use a MicroMaster to read from your UART port on your custom device. This is a one-wire command, works the same as I2C. We won't get into that. Here's a one-wire search algorithm. Right now, there's nothing. Oh, there's three. Yep, I have 3 sensors connected. So if I press S, it shows me the address as well as what kind of thing it is. So you see that it's temperature sensors. Then we have CAN. Once again, works the same as I2C. CAN command, and then we have a CAN sniffer, which is like a rolling trace of all the CAN messages on the bus. Here we have a PWM module. We can turn this on. This also has a servo page that's still kind of under development. So let's put a 50% duty cycle on a 50 hertz wave. Excuse me, on a 1 kilohertz signal. And I don't know if you can hear that, but that's connected to a speaker. So that turns that on. You turn that off. Next, we have an error logger. These are some errors that showed up from the I2C address search. This shouldn't happen, but it does. I have to fix that. But I can clear the errors by pressing C. Now, these are very verbose errors for all the communication protocols that you can check out. And then there's this task manager that just tells me all of my tasks and if they're blocked and their priority and the unused stack space for each task. All right, there's more to show you, but I'm trying to keep this video short. Thank you for watching.